So I will give you the basic demonstration of that if statement, and you can go through with that example of this if statement. So the syntax of that if statement is like that: if you write some condition, and after that condition, that you need to write this semicolon, and every time in C language or in Java language you use this curly braces over there after that if condition, and you write your thing related to the whenever the condition is true, what it need to do. But in Python you need to follow indentation means you need to follow the spaces. Like over here, if you see, if number is greater than 10, I followed a indentation over there. So whatever inside this indentation, that is related to this if statement. So if I write something over here, just below this print statement, this belongs to this one. But as soon as I break this indentation, like over here, it will come out to the if statement. Now the if condition, we write after the indentation is nothing but the space. So whenever the condition is true, I am doing something, then something. I need to write just below of this first something. This is the second something. So both of those things is belong to this statement. If I write this something over here from here, then only this first something is belong to this if statement, and second something is not belong to this one. So whenever the condition is true, only the first something is executed. If I write second something over here, so whenever the condition is true, the first something will execute, and second something also execute. Whenever the condition is false, first something will not execute, and the second something will execute. If I write something over here, but in this case, whenever the condition is true, both something will execute. Whenever the condition is false, both something will not execute. Now, if you want to write else statement with this one, so you need to write else, then again semicolon, and again follow the indentation. Now,
Yes, sir.
other thing is that apart from this one, you can write nested if else statement. The structure is like that: condition if condition is true, you are doing something. Otherwise, else if, not else if. Else if you are giving the second condition, do something. Similarly, else if condition number 2 and do something, and you can add the else one also in this one. So just I will give you one example in this one. Suppose this one is the example. We want either the number is positive, 0 or negative. Suppose the number I entered 0. I will check if number is greater than 0. So whatever, if I write something like that uh, over here. So number equal to 0 is if the number is greater than 0, number is positive. So number is not positive. And if number equal to 0, number is 0, else number is negative. So whenever if I write something over here, suppose number plus number equal to number plus 1. So this is outside this is if statement. So if the condition is true or false, whatever, this line is always executed. But as soon as I write this number equal to number plus 1, only this num equal to num plus 1 is executed only when this condition is true, because I am following the indentation, and this part this whole part is now belong to this if statement. Another thing is that you have some keywords inside the if. You can also specify the it is given over there. You can go through with that one. Now, another thing is that there is two keywords are there. One is the break, another one is the continue. So break keyword is used whenever you do not want to execute after certain point of time. For example, I am writing uh, this loop condition like that. Suppose I am iterating on the list. So we will see this one in this loop statement. In loop statement, first we will see the loop statement, then we will see this one. So the loop statement is like that. For first we there are two type of loops. One is the for loop, another one is the while loop in Python. Now the for loop syntax is like that: for variable in sequence, and we are doing something with this variable, with this variable. So this sequence can be anything. This sequence can be your string, can be your list, can be your tuple, can be your dictionary, and can be your set. It can be anything. So what it will do, if it is a string, it will take one by one character from your string and store that one into the variable. If it is a list, then it will take one by one element from the list and give it to the variable. Similarly with the tuple, similarly with the in the dictionary, it will give the keys of your dictionary to this var. In set, it will give the one by one element to your variable, and you are doing something on that. For example, in this one, there is a list containing the Swift, Python, Go, JavaScript. These are the languages. And what I am doing in this one, for language, in languages, print language. So it is taking one by one element from this list to this language variable, and now I am printing those things. Can execute this one and see the output of this one. So you can see over there the output is Swift, Python, Go, JavaScript. It is taking one by one element, and you can perform any operation with these elements. This Swift, Python, Go, JavaScript, based on your intention of your program. Another function with this one is that range. Range is used with the most of the time. It is used with the for loop. It basically works on the fly. Just leave it. I will not go depth into this one, but you can see that range function is used. Range. It is similar to your Python index slicing. You have seen in the string. There is start, there is end, and there is step size. By default, this start will be 0. By default, this step size equal to 1. So whenever I say range, sorry, range 2, it means it is assumed like that: range 0, 2, and step size is 1. And it will always execute from start to end minus 1. It is always execute to start to end minus 1. It is similar to your that slicing one. You know that slicing thing. Whenever this one is negative, what you need to do, whenever it is positive, what you need to do. So it will execute this loop 0, 1 time, 2 time only. So in this one, what I am doing, values equal to range 4. Range 4 means I am writing in this form. So it will be converted in this form, range 0, 4, 1. So it will be run 0, 1, 2, 3 times, start to end minus 1. So for loop is used whenever you know how many times you are going to execute the thing. In this one, I am saying I am executing the loop 4 times. So for loop is used that on that context. The for loop is executed when we know the iteration up to how much we need to how up to how much time we need to do our task. So in this one, like in over there, you can see in languages how many times this loop is going to execute. It is nothing but number of element in this one. How many times the loop in this one for loop is going to execute? It is only 3 times because we have specified the loop range 4. That's why 0 to 3 it will be going to execute. So in this one, in while loop, whenever you don't know the iteration, how many times the loop is going to execute, it is just one example. Over here I am specifying I equal to 1 and equal to 5. While I is smaller than equal to 5, it means until I value of I is smaller than equal to n, execute these statements. So while loop is used whenever you don't know the iteration, how many time it is going to execute. In this one, you know I'm adding 1 in this one. That's why it is going to execute only 5 times. But if I use I equal to I plus 4, so it will be executed only 2 times. Similarly, there are two keywords with this one, break and continue. Now the break will is a keyword through which you can exit your loop without running it into that much time which is intended to. For example, this loop is going to execute 5 times, but you are using this break keyword. You are saying whenever the I value equal to 3, just come out the loop. You are forcefully breaking the iteration of this loop. So whenever you execute this one, it will say whenever I equal to 3, so 0, 1, 2, whenever I value equal to 3, it will come out the loop. Got this one? When you intentionally want to break the execution of loop, then you can use this break keyword. And it always comes with the if statement. You cannot write for I in range 5 break. You need to write some condition with break as well as with the continue. Similarly, with the continue, whenever I value equal to 3, it will not execute the statement below that one. It will directly jump to the uh, uh, loop condition. For example, in this one, for I in range 5, it means it will execute 0, 1, 2, 3, 4. So I value equal to initially 0. So it will check 0 equal to 3, no. So it will print that 0. Again, it will check 1 equal to 3, no, print 1. Again 2, print 2. Now whenever it will come to the 3, I equal to 3, so it will not execute this statement because there is a continue. It will directly jump over here. It will take the another element. So you can check this output over here. So 0, 1, 2, 4. The 3 is not in the output. So we will move to the function. So in Python, the function is nothing but a set of code or functionality which you want in your program in order to get certain output, and you are using that functionality in another program also. For example, suppose you want to write a function to add two numbers. So I am writing in Python. The function is used to write in this way. Def means definition, name of your function, name of function, and its parameters. Someone call that one as argument. Then colon over there. There is a specific type of string over there in triple quotes, which is known as doc string. In this one, you will specify what the function is actually going to do. And then you write the definition of the function. For example, I am writing a function of addition of two numbers. So I am saying def add. I am specifying two arguments a comma b in this one. Now I'm writing the doc string of this one. The function do addition of two numbers. Then I say return a plus b. Now you can write this function and store in certain file. Store in certain files. Suppose one file is that where you're writing this function is utility. Now you are writing suppose two programs, one.py and two.py Python program you are writing. And suppose you want this functionality of addition, you can directly, without writing this function definition again and again in these two programs, you can directly call this function from the utility. Got this one? The idea of function is that write once and use multiple times. So in this one, the doc string, this doc string will tell you what the function is exactly doing. For example, if I'm writing this function in browser, for example, over here I'm writing this function. Def add, I'm saying a comma b. I'm saying in this one doc string function doing addition of two numbers, and then I'm saying return a plus b. Now I'm going to execute this one. Then somewhere in the program, I want to know what this add will do. I will say add dot double underscore doc. So you can see this message over here. The same message over there. Function is doing addition of two. So this is the advantage of this doc string. It will tell you that function, what actually that function is doing by using the English sentence. And another thing is that you can use this function like add, and you can provide two numbers over there, 2 comma 6. So it will give you the output of your addition. So now in the function there are certain kind of thing with the argument which I am going to tell you. Just see over here. One of the argument is positional argument. One is the argument is default argument. One is the argument is keyword argument. Another one is your variable number of argument, and another one is that your dictionary argument in this one. So whenever I say some function definition I'm writing def some function, so a comma b, if I'm writing in this form and I'm doing something on this one and returning after certain point of time some expression I'm returning. So whenever I call this function, I need to specify two value with this one because the function is accepting two arguments. So whenever I say 10 comma 20, suppose this 10 will be copied to A and 20 will be copied to B. These are nothing but the positional argument. Now the keyword argument is like that. If I say function B equal to 10, A equal to 20. Now by using this one, I already specified that B will be copied to 10, sorry, 10 will be copied to B and A will be copied to 20 will be copied to A. This is the keyword argument. By using the keyword of this function, you are specifying the value of this one. Now another one is that the default argument. For example, you are writing a function def message. You are writing name mlg1 equal to hello. I am writing the function like print uh, name print message1 plus plus name. Now in this one, if I say message python, if I say message python good evening, if I say message um, good evening, yeah, good morning, and second one is python. So these are the variation to call this function. Yes or no? And another variation is like that. Message. You can call name equal to Python and message one equal to hello. Yes, these are the variation to call this one. So this is your function definition. Now I am calling this function in this format. So the output of the first one is what? This one if I call. This one is the default argument. Message one is the default argument. Because we are not providing message one value over here in this one. So the Python will be copied to over here in the name and message one value will be taken as default. So the output will be hello Python. Now the second one is that Python will be copied to name, GE will be copied to the hello, sorry, message one. So the output will be GE Python. Now we are replacing this default value with the GE. Good evening. So the output will be GE Python. Now in this one, this will be successfully execute, this will be successfully execute. Now in this one, it will throw me an error because the rule is that the non-keyword argument cannot come after the keyword argument. It means you need to, whenever you call certain function, you cannot call like that because the rule is that I can say message Python, I can write this one, message one equal to good morning. This is valid. This is the positional argument. This is the keyword argument. The positional argument must come before the keyword argument. In this one, positional argument coming after the keyword argument. So this will not execute. This will be the error. This is the rule of the Python. And this is also fine because after the keyword argument, we are also specifying the keyword argument. There is no positional argument, no variable number of argument. Suppose I am writing this thing, def addition, and now I will say for v in n and specify s equal to 0, s equal to s plus v, and then return s. This is one of the definition. Now in this one, this is specified as variable number of arguments. In this one, you can write addition 1, comma 2, comma 3, comma 4, comma 5, and write this thing. You can also write thing addition 1, comma 2. You can write in this way. So it is taking the variable number of argument in your input and proceed accordingly, whatever for what purpose you are writing the function. In this one, the n type is by default is tuple. If you print the type of n, it will be tuple. At last is dictionary argument. For dictionary argument, you will see this type of definition: def function and you are doing something like for v in kwt and you are printing kwt v. You are printing this one. So whenever you see the double star over there, you can assume this one as a dictionary. So whenever you call this function, it will be called like that. Function one, sorry, name equal to John and address equal to some Prayagraj. You need to call in this format this function. This is the dictionary level of argument. Nobody, most of the time, people don't use this one because they directly provide the dictionary to this one. But this one is used most of the time in order to get certain functionality. Now we will see the scope of variable in the Python. Scope of variable in Python. So there is scope rule is that L E G B scope rule Python is used to follow. One is L means local, E for inclusive, G for global, B for built in. So whenever I write certain function, for example, if I'm writing this function, def search, the name of my function, and now I am writing x equal to 1, print x. Another thing is that if I'm writing this one, def search, I'm writing over here enclosing x equal to 1. Again, I'm writing def search to print x. Third one is that def search x equal to 5, and I'm writing print x. Another one is that x equal to 5, y equal to 10. I am writing def search print sum x comma y. So first one is the local. So whenever in function we write in this form, so I am writing in this one print x. So in this function, first whenever this x resolution is want, this Python want this resolution of x, first it will give preference to itself. So it will search whether the x is defined in locally within this function or not. If it is defined, it will take the value from this one. So the output of this one is 1. Another thing is that this is the local one. Now inclusive means, now suppose this is a function. Now inside this function I am again defining another function. Now in this one the Python is need to read this value x. So first it will inside the function I am defining function. Okay. So in this one in the search tool Python is trying to resolve this value x. It will first give the preference to its local variable, but there is no local over there for this function. For this function, there is no local over there. So it will move to its first enclosing function. So first enclosing function of this one is this one. So it will check, is there any x is defined? Yes, the x is defined over there. So it will take the value of x from here and print this one. Got this?
Yes, sir.
Now, another thing is that now the global. This global variable is accessible to your whole program. Now I am writing def search and print x. I am writing this thing. Fine. Now look first it will give the preference to this one local one. There is no local x over there. Outside is defined is this function is defined inside some other function? No, no enclosing over there. So this one is rolled out. Is there any global over there? Yes, global is there. So it will take the value of x from here. Now in this one, what I am defined y and x, these two global variable over there. It will take the value of x and y from global one. Now there is a sum. Is sum is defined inside this program anywhere? No. So it will try to extract this definition of sum within the Python modules. Python, whenever you install the Python, you install modules with that one certain functionality of the Python. Some files of the Python is automatically stored inside your system. On that path, you will find the definition of this sum. This is built in, which is built in means already available to you by the Python. So definition of sum will be find out within this built-in. If it is not available over there, it will throw an error. If it is available there, it will return some value to you. So the rule is that with the global, suppose I am writing this thing, def, suppose x equal to 5 over here, def, I am writing addition, suppose I am writing. Now if I say x equal to x plus 10, and then I am going to return this x. Now this x is global variable. In this context, it need to use this x because x is not locally defined over here. It will take the value of x from the global one. It will take the x from the global context and then it will return the 15. But the problem with this Python is that all the global variables are only accessible in read only mode. Read only mode. You cannot directly change over there. So in order to change this thing, you need to take the value of global x and now you can do the modification. Now it will be available in write mode also. If you write this thing, if you do not write this thing and you're trying to execute this thing, it will throw an error. Now, based on that, can you tell me the output of this one? If I'm writing def outer x equal to outer x, this is a string, def inner, now I'm writing print x, I'm calling inner this one, then I'm calling print x, and in our main program, I'm calling outer this one. Can you tell me the output of this one? So just see over here, I'm calling this outer. So control will go over here, outer. It will assign x, if x a variable which is a string, outer, outer x. Now after this one, this definition is not executed until I call this one. This definition is not executed until I call this one. So after this one, control will directly transfer over here. Now I am calling inner x. Now in the inner x, the Python will control will go, and it over here the x value we want to print. So x is not locally defined. Yes, not, it is not defined locally. So which is the first function outside this one? This one. Over here x is defined. That's why the output will be first this one, outer x, then control will left from this function because this function definition is finished. Control will left and come out over here. Then after this one, the print x will print. The output will be outer x. Two outer x will be the output. Another one is that now if I say over here def outer, now I am saying x equal to 5. Similarly, after that one, I am saying def inner, there is columns are there. I am saying x equal to 10, and I am calling over here inner, and inner function I am calling in this one, and from this one I am saying outer. From main function I am calling the outer. So in this one, what is happening in over here? First it will call the outer. For this one it will create the x equal to 5. Then it will come over here. Directly from here it will come over here. It will call then inner. Then x value. This x value will not change. This x is different, this x is different. This x is related to this one, and this x is related to this one. So another variable is created x having value 10. This x is different and this x is different. Got this one? Now sometimes I want to use this x inside over here. For that one, what I need to do, I need to write this non-local x, x equal to, now if I say 10. So what will happen over here in this one? When I call this outer, def outer will call x variable is created inside the memory. 5 will be called. Then after the control will call to the inner. Now control will come to the inner as soon as it see non-local LOCAL, NOCAL, non-local x is there, it will directly extract this x value from its outer enclosing. What is its outer enclosing? This one. So from here it will try to extract the x. So now x equal to 10 will be modified over here because we say it is non-local x. So based on this, can you tell me the output of this one? Def no global x equal to 10, def outer y equal to 44, def inner non-local x equal to 45, print x, I am calling over here inner, print x, then I am calling outer, I am saying print x, and in my main file I am calling no global. If you want to see how I'm writing this thing in that one, I'm writing this thing on the terminal. Just see over here, def no global over here, x equal to 10, def outer y equal to 44, def inner non local x equal to 45, print x, then I'm saying inner, print x, then I'm saying outer, print x non local no mm, just a minute, non local this one, think local x just wait a minute. One keyword, yes, it is one keyword. Now the definition is something like that. Now I am calling this one no global. So what will be the output? Because you know the thing of LGEB rule. Now we will move to the next one. It's anonymous function in the Python. So the thing is that if I want to add two numbers, because you know the function definition. Def add two numbers, suppose a or b. I want to add these two numbers, suppose. Then I just say return a plus b. So the disadvantage of this one is that it is taking a huge amount of space inside the memory in order to create the location for this function. So in order to resolve this one, what the people told, rather than because this functionality is because this addition functionality is a very small functionality, can I use something which do not take as much amount of space as the function used to take. This is taking the space or memory location as the function is taking, which is very high. The space of this one is very high. So people told, because the definition of my function is very small, can I use something which do not take that much amount of memory which the function used to take? For that one, they introduced an anonymous function. The anonymous function in the Python can be represented with the help of lambda. So it can take any number of value. So lambda, if I say lambda, I can take any number of values as input and it will return only one expression based on this input to the output. For example, I can say lambda, this one, a comma b, it is taking two input and returning only one expression as an output, a plus b. This function is definition is reduced with this one. Now the space is taken by this one is same as space is taken by the variable, but space is taken by this one is higher than this variable because it is a function. So you can assign x equal to lambda a comma b and then this column a plus b. It will return a plus b. So now when you say print x 3 4, the output will be the sum of this thing. Anonymous because it have no name. That's why we call this one as anonymous function. So whenever you say print x 3 comma 4, it will return you the sum of this thing. With this lambda function, we have three kind of thing. One is filter, another one is map, and after this one we have reduce. Three kind of thing are there: filter, map, and reduce. So filter is used to remove something from group or sequence. Map is used to do something which to do something with each element of group or sequence, and reduced is used to reduce your group or sequence. Now, for example, you have a list. Suppose it is containing 1, 2, 3, 4, 5, 6, 7, 8, 9. You have a list. Now you want to filter the odd numbers in this one. So you can write one function def want even. You want suppose even number in this one. X if x mod 2 equal to 0, return true, else return false. Suppose I am writing this function. So you can apply this filter method in this one. Suppose this one is a list L, and you are saying I want to filter the even number from this one, sorry, odd number from this one. If it is odd, I don't want to contain that one into the list. You can say list filter is even is your function name, and so it will take one by one element from this list. This filter function will take one by one element from this L list and apply the definition of each even on that one. If it is evaluating to true, that will be contained. If it is evaluating to false, that will be discarded. Another thing is that you want to do, suppose map, you want to double the each element of your list L1. So you can write one function def double x return x into x. For that one, you can use the map one. List map, you are calling double on each element of your list. When you want to do something with each element of group or sequence, and this one is used when you want to remove some element from the group or sequence. This filter is used. Suppose my list is L equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I want to map each element as double. So I can write this one map lambda x, it is taking one element and it is doubling all those elements x into x comma f. Suppose I am running this one. So you can see only one address where this map is generated. Yes or no? You are not
Yes.
able to see the thing. So in order to extract the thing from this one, I am converting whatever the output the map is giving to me. I am converting that one into the list format. Then it
Oh,
will give me the list of this. Now you can say 1, 4, 9, 16, 25. This one. You can write either whatever the form you want. You want in tuple, you can write that tuple over here. It is up to you. Similarly, there is a reduce function. Reduce is used to reduce your whole sequence. For example, sequence is nothing but your set is there, your dictionary is there, your string is there. But I am considering the example of list. Now, map is used to reduce your whole list or whole sequence. So, sorry, reduce. So, if I write reduce, reduce lambda x comma y x plus y comma l ret, just loading this one. Reduce is found in, I think, in some library it is found. Okay, reduce is in this library actually. From font tools import reduce. Uh, I'm forgetting about the library. I'm just give me a time. I will checking this one based on which library it is there. Reduce. Font tools FUNC. QNC tools. It is there. Now, reduce you will get over here. So what reduce will do, it will take one by first it will take the two element from your list. So it will take 1 and 2. The sum of that one is 3. Then it will take the third element. Then 3 plus 3 is 6. Then fourth element, then fifth element, then sixth element. So after that you will get only one number. Are you getting? First it will take the two numbers from your list because I supplied the list over there. It will take the two number, 1 or 2. The sum of that one is 3. That one is stored in the X. Now it will take the 3, only 3. So first number is 3. The sum of these two element is inside that X. Second element it will take, it will stored inside the Y. Then sum of these two will be stored again in the X. Then it will take the 4, store into the Y. The sum of these three number is stored into the X. And in this way, it will do the work until your list is going to reduce to the single element. So how the reduce is going to work? Because you have a list over here. I am supplying the list over there. Fine. So first, within the list, it is taking the two numbers, 1 or 2, 1 and 2. One is stored inside the just see. One is stored inside the X and Y will store the 2, the second element of your list. Fine?
Yes,
Fine.
sir.
So 1 is stored inside this lambda X and Y is stored inside, or 2 is stored inside the Y. Now the sum of this one, 2 plus 1, 3, which now is stored inside the 3, Y will take nothing from right now. There is no value with the Y. Now the Y will take the third value of this one. So third value of this list is 3. The value of X is nothing but the sum of previous two elements. So now X and Y value is available over here. So 3 plus 3 is 9. So 9 again will be stored over here. Y will take nothing. It will take the next element from the sequence, which is nothing but your 4. 9 plus 4 is 13. 13 again is stored inside the X. Now it will take the next element from your list, which is nothing but the 5. And in this way, it will perform your addition until it gets the single element. So these three functions are also there and they can be used with the anonymous function as I have done over here with the anonymous function, and they can be used with proper function. This thing, map, filter, reduce, we have seen. This is up to the function. Lastly, we will see one thing and then we will move to the our DNA toolkit is that list comprehension. List comprehension is there. So suppose we have a list containing certain elements and we want to filter out certain element from this list. Based on that, it do not contain the n. Suppose apple, there is no n inside in apple. Banana, n is there. Orange, n is there. Strawberry, n is not there. Fine. Suppose we want to filter the elements which is containing n. So what I am writing in this one, I am creating a new list, empty list. Then I am extracting each of the element of my this earlier list, which is stored inside the value. So first it will take the apple and it will check whether that apple contain n or not. So apple do not contain n, so condition is true. So L2 will contain that apple. Similarly, it will take the second element banana. Since banana contain n, so it will not add it to the another list. Similarly, the orange is there containing n, it will not add into the L2 list. Similarly, strawberry, it do not contain N. That's why it will be able to eligible to add into the L2 list. So this way I am going to filter the thing in this one. So this is a general way to do filtering. If you are writing the code in your value model like C, Java, the general way to filter the thing is this one. But in Python, you can do the same thing in this way. What I have done over there, I am writing the same thing as I wrote in this loop for x in L, for value in L, or I used x over here for x in L. If n is not in the x, put into the this L2 list. So I am taking those x which do not contain L, n in their value. So this is the list comprehension in the Python. If you want to see the output of this one, I am just running this one. So L is our list. Now L2 will contain those elements which do not contain N. Similarly, in this one, L2 will contain those elements which do not contain N. So you can do this thing either this way or this way. So in Python, try to use this thing, try to use this thing only when you have only one for loop. You can work with the two for loop or three for loop with this statement, but the readability will so it will reduce the readability. If there is only one for loop, you can write in this, which will be fast. The last one in this one is module. After that, we will move to the DNA toolkit. So module, in order to explain this thing, I created a one folder in my PyCharm and I created two files, main and module.py. Now the module is nothing but when we have certain functionality which is totally related to each other, we put all those functionality into a one file and we call that one is nothing but a module for particular kind of task. Module is nothing but collection of functionality related to single task. For example, in later session we will see a DNA toolkit, DNA. In that one, what we do, we write all of the functionality related to DNA in one file, and that file is nothing but considered as the module. For example, in this one, in one folder, BIC class I created. In that folder, I created main.py and module.py. So, in this module.py, I will write the related functionality into a one file. That related functionality are nothing but the module. So, in module file, I am creating in module.py file, I am creating the arithmetic operation, related arithmetic operation function. I am creating this one. Now, suppose I need this function in my main file. This is the module file. Now I am switching to the main file. Now, how to call this functionality in order to get our task? I need to tell import module. That's it. Import module. It will automatically extract the thing from that one. Just see over here. If I say print module, what functionality I want to extract from that one? Suppose I want some add over there. So I put the dot over there. The functionality is coming out from that one. Either you can take add, either you can take divide, either you can take multiply, either you can take subtract. So module dot, suppose I want to add the thing, add 2 comma 3. So if I run this one, just a minute, module dot subtract, suppose I want 2 comma 3. So it will give me the functionality of subtraction also. The first one is 5, second one is minus. Now suppose I want only one functionality from the module. So I can write this thing. Now suppose I want only one functionality. Suppose I want subtract only from this one. So what I need to do, from module import, subtract. Now only one functionality will be imported from this one. Now if I say print subtract 2 comma 3, so now I am not doing module dot because I directly extracted the subtract functionality from the module. So I can run this one directly. Now if I say after this one I want add functionality, I will not able to get that one. So if I say module dot add 2 comma 3, suppose if I say like this, so it will throw me an error. It will say module is not defined because I am saying I want only subtract functionality from the module, I do not want module, but I am using the module in this one.
Yes, sir.
Or if you want to extract all functionality from your module, you can use this thing, import star. Now I can say print add 2 comma 3. So it will extract all the functionality star inside the module. Inside the module, there are these functionality are there. By using star, I am saying I want all functionality from that one. If you do not want all functionality, you just specify the name of that one. Suppose I want add, comma, subtract. Only two functionality. If you want one functionality, you can directly say I want that specific functionality. If you want all functionality, you just say star. So now I will be giving you some assignment on this up to here, whatever we have learned. And in the next session, we will be going to discuss the DNA toolkit. If the time permits, we will be going to discuss the assignment also. Otherwise, I will provide you the solution of that one.